How is it possible to fly from Sydney, Australia to Santiago, Chile in 12.5 hours?
It was a colourful start for QF Flight 28 to Santiago, with Chilean dancers performing their national dance at Sydney Airport, giving passengers on the plane an exciting send-off for the 13-hour non-stop journey to this new Qantas destination.
Well, from what I can see, these flights really do exist. The TV station shows the flight going north of New Zealand to get there. Here we have the YouTuber Max Egan taking this flight from Sydney to Santiago, as you can see in this video. He videos himself standing at Sydney Airport in the departure lounge. He pans to the flight board to show the flight he's about to take, which shows the flight number QF27 to Santiago. The plane he is taking is the new Boeing 747-8 series, which has a top speed of 1,000 kilometers an hour. But with a strong tailwind, it can reach ground speeds of 1,500 kilometers an hour, even if the plane is at its maximum speed of 1,000 kilometers an hour. During the flight, he videos the flight route on his in-flight TV screen, which shows a different route than the TV station flying under New Zealand. By taking this route under New Zealand, the plane will travel with extreme high winds, which are called the Roaring 40s, the Furious 50s and the Screaming 60s, which even on a flat earth, the plane could cover these distances without a problem. Now on the return trip from Santiago to Sydney, the flight time is much different, with the average time of 19 hours and 10 minutes. This is almost 7 hours longer on the return trip because the winds are much weaker, but still give the plane a tailwind when flown at a higher northern path. As you can see from the winds that circle the flat earth plane, they are extremely fast flowing air currents, and planes can use them to cover long distances at high speeds.
I think I understand the southern flights a little bit more than I used to. Once I understood what ground speed is and indicated airspeed, and once I got that all down, then it made a lot more sense to me. I mean, here's what we have to know, just so you can kind of see where I'm going forward with that, is if you just think of the southern flights and the fact that there is about, 2,500 miles is a guess, difference between, let me bring up a flat earth map, just so we can look at it together, but you'll see, oops, that's not what I wanted to do, there we go. And I'll just kind of show you what I'm talking about, because once I kind of realized this, then I was like, oh, okay, I get it now. That's a good one. Okay, so we're going to be looking at this image here. Down. Okay. So when you're talking about Australia to Chile, and we know that Max Egan took that flight, took him 11.5 hours, and the miles on that flight is 7,000. Okay. So doing that distance, if we get a little calculator here, and we say they went 7,000 miles, and we divide that by 11.5, okay, we get 608 miles per hour, okay, which makes sense. That's about what planes go. We know that, so everything seems to jive, right? Yet, I've shown, other people have shown that there are, and I guess we could show this too, might as well, while we're here. If we go to earth.nullschool, we're going to figure out if there's any jet streams that those planes could be possibly getting into. Another thing that we've changed, I don't know if people know this, but when you get to this site, it used to be right on the azimuthal equidistant. Now when you bring that up, it actually starts with Australia in the middle, Antarctica in the middle, which is just funny because it didn't used to do that until flat earth started being talked about. You have to kind of flip yourself your own little map here. Okay. So when we do this, all of a sudden things start looking a little bit more like they make sense. So we're doing wind, and then we're going to go height. Well, in between 250 and 700 is the jet streams, or is about 35,000 feet. 250 is about 32,000 feet, and 70 is about 45,000 feet. So, it'd be nice if they had like a 150 in here, but they don't. So when you look at these jet streams here, remember we were talking about a flight going from here out of, Australia. I can't really see where it's at now. Hello. Okay, over here. Oops, right about there. Okay, so it's coming this way. We know that they're circling this way. And if you catch some of these winds, that's 166 kilometers per hour, 186, 203. Oops, that's too far. Getting over here, we got 147, 201, and this is like too much this way. Are you there? Okay, and then if you go even higher, so let's go up to the 70 here, then you can see you've got winds at 116, at 100. Okay, so you've got all the, now here even higher, you've got even more. Okay, and this is probably around 45,000 or higher though. But you've got 153, 165, 177, 151. These ones here are flying around. And these are the polar winds. And the southern polar winds are year-round. They're not as variable as the middle is. And so what you've got now is, here's what we got to believe. We just found out that there is definitely air currents going. So what is more plausible? You know, that the plane is going 608 miles per hour and is not having any wind? We just saw that all the wind is going in that direction. So if you believe in trade winds, which everybody should, because that's how planes fly and that's how they cut time, and that's why planes going generally in an east direction are faster than coming west. So if you believe that, then what is the reason the plane is only going 608 miles per hour? What you have to believe is, let's say that those planes are going 150, or there's 150 mile per hour wind. Well, then you have to believe that that plane is actually going only 450. Because that's what it means when you're being carried by the jet streams, that that only can be measured by ground-based tracking or GPS or with known distances. So what I'm trying to say is, if this was actually 2,000 miles longer, okay, so let's say this is a much more vast area, that all you would need to do is get that plane up there and going a little bit faster, and nobody would ever know. Not the pilot, not the people who are tracking the plane, not the people flying in the plane, not the passengers, nobody. Because there's nothing to tell you that what's happening. Basically, we know that they can add that 150 miles per hour to that speed. And again, if you take that, let's just take 150. So if instead of 608, now we add 150, now we've got 758 miles per hour. And then you can times that by the 11.5. And that's just, now you've got 8,717. So now you've got an extra almost 2,000 miles, 1,700, and that's a low estimate. And again, that 11.5 hours is a quick flight for that way. And then going back, it takes 14 hours, which makes sense. We just saw that the jet streams are usually going the other direction. So really, just something that I think I've changed my mind on before. I was a little bit confused how that all worked, but now it's like, well, wait a second. Either I have to believe that the plane is going a lot slower than it can go, because it doesn't affect, the speed of sound when you're being carried by the wind, because the speed of sound, you would break the sound barrier if you're cutting through the wind at that speed. But if you're being carried by any trade winds, you just set the plane to 0.95 Mach and go. So either you have to believe that the plane is going 450 for some reason. I don't know why. No planes go just cruising at 450 for some reason, and then letting the jet streams pull them up to 600. Or the plane is really going as fast as it can, probably 650, plus an additional 150 miles per hour that makes up that distance. Again, the reason this would not be known is because if all they can base it off of is ground speed. So it's basically how much distance is the plane covering in a certain amount of time. Well, if there's a deception there, nobody would know. You just have to accept the fact that the plane is actually going 450, being carried with winds, and for some reason the plane doesn't maximize its fuel efficiency and actually get up in the winds and go as fast as it can. It just feels like cruising. I don't believe that, and I think that's the answer. That if it were true that and there's a lot of people out there that think southern flights disprove the flat Earth, and actually the southern flights prove the flat Earth. So, or at least evidence towards it. So, amongst many others. So let's go back and see if there's any more chat here. What was I saying before we got on that? I took a diverge, didn't I? I was going to check if anybody had any questions. I see people punching in questions on ask.fm. I'll get to those after. Let's see here. So what is hilarious? You can't just say it's hilarious. It's hilarious that people question where they live when they're given no evidence. That's what's hilarious, I guess. They probably do cancel the flight when the winds are low. I wouldn't doubt that. Again, here's another thing, is if it was real, the distance was exactly like we're given. People say, how could you question the distance? It says it's 7,000 miles. Then show me a cruise that goes from New Zealand to South America. There isn't one. Well, there is if you go up to Japan and up to Alaska and around down by, California and then down to the South America. But where's the boat that goes straight across? Well, there's not one because boats are not like planes. Planes can have the variance we just talked about of 200 miles per hour that nobody would really notice, but a boat cannot go more than 20 miles per hour. Sure, if it's got a current with it, maybe it's going 24. If it's going a little slow, it's going 18. But a cruise ship cannot make up that distance in the amount of time. They would be 5 days overdue. So,
in this video, I'm going to show you how to calculate and measure the distance from Sydney to the pole and from the pole to Santiago, and to circumnavigate from Sydney to Santiago. At the end of this video, I'm going to show you that it is possible to calculate a straight path from Sydney to Santiago. But I will show you in another video how I did it. Don't forget to check some great FlatEarth channels in the descriptions below. Again, the distance map is scientifically and practically correct. I had a wonderful discussion with this person on the internet. His name is Hashmal Don, and he wants to know the distance between Sydney, Australia and Santiago de Chile. In the first part of my video, we found the coordinates for Sydney, and we're going to do the same for Chile. But let me zoom in and see if we can find Chile. This is Chile, and we need to find Santiago de Chile, with the capital Santiago. Santiago is not written on this map, but there's another city, Valparaiso, and Santiago is west of Valparaiso. So I see a dot, a circle, a very small circle here. So I suppose this is Chile. But for the purpose of our demonstration, we can assume that this is Chile and we'll use it as Chile. In the first part of our video, I'll show you how to find the coordinates for Sydney. We measured them and we pinpoint Sydney and we found the location, the coordinates 34 and 151. So let's find out the coordinates for Santiago. We don't really need it to measure the distance from Santiago to Sydney, but for the purpose of our demonstration, let's just measure the coordinates. Let me zoom in. As you can see, Santiago is between two latitude lines. This is 30, between the 30 and the 45, between these two. You can see it, yes. So we have to measure the distance in degree from Santiago to the 30 latitude line. Let me put a marker. So there it is, to pinpoint Santiago. And the first part of the video, I still have my scale. So we're going to measure how many degrees are between Santiago and the latitude line. Well, let's say 3. I hope you can see it. 3 from this small circle to the latitude line. We measured 3 degrees. That's from latitude line. This is the 30 latitude line plus 3 degrees. It's 33 degrees below the equator, minus 33. The latitude is minus 33 west of meridian of Greenwich. Now we're going to measure the longitude line for Santiago, and our marker shows that Santiago is between the longitude 60 and the 75. So Santiago is somewhere in between. So I have my piece of string. I prefer to use dental floss. So let's measure the longitude and let's find out. So I will zoom in later, because first I would like to measure it from the center. Make sure it's on the longitude line. I hope you can see it. Keep it stretched and then move until you reach Santiago. I hope you can see it. It is somewhere between 71, 71.5. Looks like 71.5. I hope you can see it. I will zoom in, but first I have to hold the center with a magnet so I can zoom in for you to see. So I placed a magnet on the pole to hold my string. Can you see it? Yes. Yeah, this is it. I placed a magnet to hold my string, and now I'm gonna measure. Just check. Oh, yeah, just check if it's in the right spot on the center, and then move until you reach Santiago. And it's about 5. It's 65, 70, 71.5. Well, for the purpose of our demonstration, we say 71.5. I hope you can see it. It reached Santiago, 71.5. Let me hold this one and move the camera so you can see the magnet. This is my magnet. Don's question is to measure the distance between Sydney and Santiago de Chile. We're going to measure the distance from Sydney to the North Pole and from North Pole to Santiago de Chile. And the next one, we're going to measure the distance from Sydney, circumnavigate to Santiago de Chile. In this case, it's going to be easy because we know our coordinates, we know the locations. So the only thing we need to do is to measure how many degrees lies between Sydney and the North Pole and from the North Pole to Santiago de Chile. We know Sydney is 34, so at a 30 latitude line plus 4 degrees, and Santiago de Chile is on the 30 latitude line plus 3 degrees. So we can measure all the way up to the North Pole for both locations. Sydney. From the North Pole, it's 1, 2, 3, 4, 5, 6, 7, 8 plus 4 degrees. So it's 84 degrees from Sydney to the North Pole. From the North Pole to Santiago de Chile, it's 1, 2, 3, 4, 5, 6, 7, 8 plus 3 degrees. From the North Pole, all the latitude lines. This is the equator. From the North Pole, we have 15 degrees, and then 15 degrees, 15, 15, 15, 15, 15, 15. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 times 15 degrees plus 4 degrees to reach Sydney. Let me put it this way. From the North Pole, 1, 2, 3, 4, 5, 6, 7, 8 plus 3 degrees to reach Santiago. It means the distance from Sydney to North Pole, it's 8 times 15 degrees for each latitude line plus 4 degrees to reach Sydney. That equals to 124 degrees times 60 nautical miles makes a total of 7,440 nautical miles. We do the same from the North Pole to Santiago de Chile. The distance is 8 times 15 for the latitude lines. It's 8 times 15 plus 3 to reach Santiago. That makes a total of 123 degrees multiplied by 60 nautical miles, and you get the real distance. That's 7,380 nautical miles. So the total distance from Sydney to Chile is 7,440 plus, that's the distance from Sydney to the North Pole, plus the distance from the North Pole to Santiago de Chile, and that makes a total of 40,820 nautical miles. And that's 37,464 kilometers. The question is, why 60 nautical miles? To find the answer, we have to read between the lines. And it says 60 miles to the degree. It means for each degree is in reality 60 nautical miles. Scientifically and practically correct. Navigate from Sydney, Australia to Santiago de Chile, we have to count the amount of degrees between Sydney and Santiago de Chile. That's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 times 15 degrees. Each longitude line is 15 degrees plus 14 degrees. This is 5, 10, 11, 12, 13, 14, because this is 1 degree. And on the other side, it is 1, 2, 3 and a half, because the other way is 71 and a half. So So we have to add 3.5 on this side and 14. It makes a total of 14 degrees plus 8 times 1, 2, 3, 4, 5, 6, 7, 8 plus 3.5 degrees. We get the total amount of degrees. To circumnavigate from Sydney to Santiago, it's 14 degrees plus 8 times 15 degrees for the nautical miles plus 3.5 degrees to reach Santiago. That makes a total of 137.5 degrees. 137.5 degrees multiplied by 60 nautical miles, that makes a total of 8,250 nautical miles. That's 15,279 kilometers. These are the distances I calculated from using the Gleason's map from Sydney to Santiago, from Sydney to the North Pole, and from North Pole to Santiago. This is the distance I calculated to circumnavigate Sydney to Santiago. And if you fly in a straight line, this is a flat plane, the distance will be shorter than 8,250 nautical miles. These measurements are based on the Gleason's map. I showed you how to measure distances using the Gleason's map. You can measure latitudes, longitudes, but you cannot measure in a straight line. Of course, you can fly straight to Chile, but you cannot measure a straight line. You cannot, because the Gleason's map is not scaled that way. It's a different ratio. You can only measure using the longitude or the latitude lines. And like I said before, this is not a scale to measure from one place to another. This is an 1892 conversion. By using this, I calculated a direct flight from Sydney to Santiago in a straight line. At this moment, I'm just showing you the calculations, and in my later video I will explain it, because you won't be able to understand it at this moment. Some local believers think when you fly from Sydney to Chile, you fly like this. In reality, you fly like this. But if you believe you fly like this, whatever makes you happy, as long as it's a safe flight. Ashmal done. I hope I answered your question. Thanks for watching.